This lesson is for FST, Lesson 2.6 on quadratic models. The quadratic equation that you're going to be working with is ax squared plus bx plus c. Keep in mind that the a value determines which way your graph will point. The graph shape is going to be a parabola. But keep in mind that the word quadratic is associated with the actual equation. So when the a value is positive, your parabola will open up and the vertex point will be at the minimum. If the a value is negative, the parabola will flip upside down and the vertex point will be a maximum. Keep in mind that the b value and the c value may not be present. Either the b could be a 0 or the c could be 0, or they both might be 0. So know that you don't always have to have all three components to be considered a quadratic. The c value in the equation is the value for the y-intercept. So just put a 0 in for the x value and the y-intercept will show up as your c value. The vertex can be found by finding the two x-intercepts, but typically it's faster to calculate the vertex as the opposite of b over 2a. Calculating that will give you just the x portion of the vertex. Taking that value that you get and plugging it in for x will allow you to generate the y portion of the vertex. So we're going to practice that with an example momentarily. The x-intercepts can also be found. Keep in mind that the x-intercepts, there are three different possibilities. When you graph a parabola, it is possible that the parabola never crosses the x-axis, so it is possible that there are no x-intercepts. It is possible as well that the parabola intersects the x-axis just one time, and so it will have one x-intercept. And then of course it is possible that the parabola will cross twice, giving you two x-intercepts. The reason for the three different possibilities is because of these three situations, and the formula that will generate those three outcomes is the quadratic formula. Some people have set the quadratic formulas list to music using Pop Goes the Weasel, so feel free to look that up or Google that if you'd like. It might help you remember the formula itself. The formula is opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Remember that when you calculate this, you're actually doing it twice, once with a plus, once with a minus, so potentially you could get two answers for the x-intercepts. If you get one answer, basically what's going to happen there is the two answers are identical to each other. And if you get no answer, that's because when you're doing your square root, you might get a negative underneath, and we can't do the square root of a negative number. So it is possible to get either 0, 1, or 2 answers. So let's go ahead and put these calculations into practice with the example that's given. Find the vertex and all the intercepts for negative 3x squared minus 4x plus 7. My recommendation to students, very strong recommendation, is to list a, b, and c separately. Students who just grab them right out of the equation tend to make mistakes, particularly when it comes to positives versus negatives. So I would recommend writing them down and writing them separately from the actual equation. The a here is the number in front of x squared. If you're wondering where a, b, and c came from, it came right from our quadratic formula or quadratic equation here. A is next to x squared, b is next to plain x, and c is all alone. So the a value here is negative 3, the b is, careful, negative 4, and the c is positive 7. So I'm going to go ahead and start calculating the vertex first. The vertex is opposite of b over 2a. The opposite of b is 4. It was negative, I'm taking the opposite of it. And I divide by 2 times a. 2 times negative 3 is negative 6. If I reduce that fraction to lowest terms, I get negative 2/3, divide them both by 2, and I just move the negative to be in front of the parenthesis or with the top number. You could also list that as a decimal, so that would be negative 0.6 repeating. Be careful here not to say negative 0.66 repeating. So this is the x portion of the vertex. To find the y portion, we would simply plug that number into the equation for x and we'd calculate. I've done that on my calculator, so I'm just going to display that next. So right here, I've shown negative 3x squared minus 4x plus 7, and for the x location, I went ahead and filled in negative 2/3. So when I calculated that and hit enter, I got 8.3 repeating, or 8 1/3. So let's go ahead and write that. So keep in mind that the vertex is a coordinate, So let's write our answers in coordinate form. So the vertex is at the point negative 2/3 for x and 8 1/3 for y. Let's just call that the vertex. For the y-intercept next, remember that the y-intercept is simply the c value, and you just need to write it as a coordinate. So the y-intercept is going to be the coordinate 0, 7. That's the y value, the other value has to be a 0. For the x-intercepts, we're going to go ahead and calculate the quadratic formula. So we're going to grab these numbers and calculate from the formula from before. So opposite of b is 4 plus or minus the square root of b squared. B squared, be careful on your calculator, one more time here. When you do negative 4 squared without parentheses, the calculator gives you an incorrect result because it doesn't associate the negative and the 4 as being together. You need to put it in parentheses so that the calculator knows that you're doing a negative 4. On this previous one, it's going to do the power first, according to the order of operations, and then it's going to take the opposite. So if you want that opposite to travel with the number, you have to put it in parentheses. The other thing you can do here is simply remember that when you square a negative number, you get a positive. So negative 4 squared is positive 16. From the formula, right here, this is a spot where kids tend to make mistakes. That is a subtraction sign, not a negative 4. So leave it as minus and calculate 4 times a times c. 4 times negative 3 times 7 is negative 84. I will be subtracting a negative later, and that means I'll simply be adding. And then on the bottom I do 2 times a. 2 times negative 3 is negative 6. For my next calculation, I'm going to work underneath the radical. And when I add the opposite here, I'm going to get 100. Square root of 100 is 10. So my next calculation is 4 plus and minus 10 over negative 6. Be careful here when you do your division, make sure that you're doing the plus and the minus first and then dividing last. So I'm going to get two answers here. On the top, I'm going to do 4 plus 10, which is 14. And on the bottom, I've got my negative 6. When I subtract, I'm going to get 4 minus 10, which is negative 6, divide by the bottom, which is also negative 6. So when I calculate here and reduce that fraction, I get negative 7/3. Over here, I'm just going to get a 1. Keep in mind that these two answers are separate from each other. They are both x-intercepts. X-intercepts are listed as coordinates. The values that we got are the x values. The other part of the coordinate is simply a 0. So I got negative 7/3 as one of my x-intercepts. The other x-intercept was 1. We just put a 0 for the y value. I want to do one more thing with students as it relates to quadratics. Typically, quadratics are what we experience in real life when things are thrown or dropped. Things that are thrown or dropped are referred to as projectiles. Typically, this equation will be given to students within the word problem. Students will simply have to remember what all the letters stand for and substitute the numbers in correctly. So the formula here is height versus time. Time is our independent variable, and then the height is determined by the time. When you throw or drop something, the path that the object takes is typically a parabola. So let's draw a quick picture here. Let's say that you're standing right on the origin and you're standing straight up and you take something, an object, and you throw it up in the air. The path that you just drew, or the path that just happened, is an upside down parabola. So since it's upside down, it has to have a negative a value. We don't quite know what the a value is yet. The a value is going to be found by you taking negative half times the gravity component. Gravity is going to pull the object down, and so we need to account for that in the equation. If you're doing the problem on Earth, the gravity component will either be 32 if it's in feet, or 9.8 if it's in the metric system, or in meters. The t will be your variable, just like it says over here. Make sure that you do t squared at the beginning to get your parabola shape. V sub 0, or V sub O, is referred to as the initial velocity. When you're starting or standing right here and you're going to throw that ball or that object, it's going to have some force behind it when you let go. Different people will have a different force or a different velocity or a different speed, so that number needs to be incorporated into the equation. So typically that number will be given to you in the word problem, you just simply substitute it in. Don't forget the t value. There is a t that needs to be next to that velocity, and typically it'll stay t as a letter. The initial height will also be incorporated into the equation, and that's labeled here as h sub 0. So how high are you off the ground when you let go of the ball or the object? That needs to be incorporated as well. So object or projectile, that's what we're talking about, and it's an upside down quadratic situation. Typically when you're doing these types of real world problems, they're going to ask you two basic questions that you need to use your math skills to answer. When does the object hit the ground? We would identify that as being these locations here, and we would associate those as the x-intercepts. Keep in mind that for a real world problem, you will ignore any x-intercepts that are negative. So we're going to say positive here. Positive x-intercepts are the only ones that we care about for when it hits the ground. And so to find or calculate the x-intercepts, we have to do the quadratic formula. How high does the object get? On our picture here, that is indicated by the vertex. So to find the vertex is how we would answer this question. Find the vertex. Keep in mind that our formula for the vertex, opposite of b over 2a, gives us only the x part of the vertex. We need to plug it back into the equation for t. So we'll call that t then instead. Plug that back in for t in order to find the actual height. So let's put that into practice with a word problem. So this information here is from number 6 in students' homework, and I've simply just repeated it here, so students don't need to copy it down. So take a moment to read the problem itself, and we're going to go ahead and write our equation. So h of t is -1/2. The g component on this one, because it's on the moon, is the acceleration due to gravity. They give you that number as 1.6. Don't forget the t squared. Next number you need is the initial velocity. If you read carefully here, it is 20. And then the initial height is given as well as 15. Be careful here. I wouldn't recommend that you leave your answer like this because the a value is not quite finished yet. We multiply -1/2 times 1.6. We get our final answer, which is -0.8 t squared plus 20t plus 15. So be careful there, our a value is -0.8, not -1/2. How high is the ball after 3 seconds? To figure that out, you'd simply just fill in a 3 for t. So you'd calculate here with your calculator -0.8, 3 squared plus 20 times 3 plus 15. And when you calculate that, you should get 67.8 if you round it to the 10th. How high will the ball get? We'd want to be calculating the vertex here. And so for the vertex, we're going to do opposite of b over 2a. Opposite of b is going to be -20. 2 times a is going to be -1.6. When you divide that out, you get 12.5. Keep in mind that that is a time. So after 12.5 seconds, the ball will reach its highest point. We still don't know how high it will be after that amount of time. So you have to plug in 12.5 in for t into the equation. So we'll do -0.8 times 12.5 squared plus 20 times 12.5 plus 15. So it's the same as what we did in part B. We just had to find what the x value was first. So 12.5, you fill that in for the t value, you get 140 meters. So that's your final answer then for part C. And then I'd like students to go ahead and do the final question here on their own. Students typically need the most practice on the quadratic formula, and that's what you'll do here to answer part D. So I'm going to pause the video here and just simply give you the answer at the end. So here's the answer for students. I've listed my ABC, I've done all my calculations, and when I was all done, I got 2 answers, a negative and a positive. The negative one we are going to ignore because that would be time in the past. So at 25.7 seconds, the ball will hit the ground. Lastly, I want to give students information for quadratic regression. It's the same information as what we did on a previous lesson for both linear and for exponential regression. Steps are the same. The only thing that changes is right here. You want to choose quadratic regression versus the others. Be careful here. There is a quartic available in the list. Make sure you don't choose the wrong one.